Hello. So for today's doubts, I got these two questions. Uh, so the first, I'll be discussing question number 4 here. Question number 4 is a classic example of telescoping series. What we can do for this question is we can write general term T of k is equal to, now because k square is written, we can write this as 4 if I do 1 by 3. And then if I'll be writing 4 into k square minus 1 minus of k square minus 4, I can see the constant getting cancelled and we'll be getting 3k square upon 3 will become k square, right? So the entire thing into 4 is the per k, if I write, I get the exact numerator upon, I can write k plus 1 into k plus 2. Now I can split about this minus sign. So I'll be getting this as 1 by 3 into k minus 1 upon k plus 2, then 4 is the power k plus 1 minus k minus 2 upon k plus 1 into 4 is the power k, right? Now this is tk. If I have to write s of 25, I'll be getting, so the smaller function and the second function I have to put k equals 1, the first function I have to put k equals 25. So I'll be getting 1 by 3 into, I will put 25, I'll be getting 24 into 4 is the power 26 upon 27 minus of. Now, if I put k equals 1 here, reading minus 1, so I can write it as 4. 1 into 4, that is 4 upon 2. So I can take 2 out. So I'll be getting this as 2 by 3 into, I can write in power of 2, 54 by remaining would be 9 because 3 will get cancelled, and plus 1 here. So this is the answer for question number 4. So option here should be B option, right? Now I'll discuss question number 3 here, right? So if I discuss question number 3 here, I can see, okay, I can see if I write till n terms, as in the question number 3 here is, the increasing sequence 1, 3, 4, 9, 10, 12, 13 consists of all positive integers, which are powers of 3 or sums of distinct powers of 3. So basically in the question they are talking about all the powers of 3, like 1, 3 is the power 0, then 3 is the power 1, 3 is the power 2, till, now if I take n terms, it will be going till 3 is the power n minus 1, right? Now till these are total n terms here, the powers of 3 n terms. Now, if I have to write the total combinations of this, the total combination would be 2 raised to the power n, because each term has two options. Either that particular term will come or not come in the sum. So total would be 2 raised to the power n. But if all the terms, neither of the terms are coming, then 2 raised to the power n minus that case we can't take, because at least one should be the sum, right? So minus 1 would be the total combinations or the total sums possible, at least one case we are taking. So total sums possible till 3 raised to the power n minus 1. If we take the sequence, the powers of 3 from 1 to 3 raised to the power n minus 1, as in total n terms, we'll be having 2 raised to the power n minus 1 combinations, right? Now, because they're asking in the 100 terms of the sequence, they're asking 100 terms, right? So we have to think in power of 2. So let's say we want, we can take it till 2 raised to the power 6, because we know 2 raised to the power 6 is 64, right? So let's say we take the terms from 1 raised to the power 1, 3 raised to the power 2, till 3, we want 6 terms so that we get 2 raised to the power 6 over there, right? So we have to take till 3 raised to the power 5, right? So if I take all the combinations till 3 raised to the power 5, I'll be getting 2 raised to the power 6 minus 1, that is 63, right? So I get 63 possible integers, right, in the sequence. So 63 distinct integers in the sequence, right? Integers in the given sequence, right? So I can write till 63 distinct integers using 1 till 3 to the power 5, right? Now I have to introduce 3 to the power 6 here, right? So let's say I introduce 3 to the power 6, right? So 3 to the power 6 will be there in the sequence. Now I have to introduce 3 to the power 6 if I want to get the greater integers in the sequence, right? So 3 is the power 6 I introduced. Now, what I will be doing is this 3 is the power 5 I won't be taking in the sum, okay? Then remaining terms, what I'll be doing is I'll be taking 1, 3 is the power 1, 3 is the power 2, 3 is the power 3, till 3 is the power 4. Now here the total number of terms is 5, right? So I should be getting 2 raised to the power 5, that is 32 different elements in the sequence, right? So 32 distinct integers. This is including when any of them or neither of these are selected. As in that case, I'll be getting 3 to the power 6 as the total sum, which is acceptable, right? Because 3 to the power 6 we have not counted earlier, right? So here we can take 2 to the power 5, which is 32 distinct integers in the sequence, right? In the sequence. Now these numbers will be greater than the numbers we have talked about earlier, right? So if I add these two, I can see adding these two, I get 63 plus 32, which is 95 elements. Till 95 elements we have talked about now. So we have to talk 5 more elements, right? So let's say if I take 3 to the power 6, I'm including 3 to the power 5 because if I want to write 3 greater numbers, I have to include 3 to the power 5 now because earlier I have not included. Now 3 to the power 6 is included, 3 to the power 5 is included. Now, if I want 8 numbers, I'll have to take first 3 elements in sequence. That is 1, 3 to the power 1 and 3 to the power 2. So let's say if I don't include 3 to the power 2, then what will happen is 1 3 to the power 1 if I include, I get total 2 raised to the power 2. Okay, that is 4 distinct elements. In this case, elements in the sequence, right? In this case, I have taken the case when neither of 1 and 3 to the power 1 are selected. As in that case, the number selected will be 3 to the power 6 plus 3 to the power 5. As in these two numbers will be selected, right? So till here we got total 99 elements, right? Now the next number in the sequence would be 3 to the power 6, 3 to the power 5, and 1 3 to the power 1 we have already included. The next number will be 3 to the power 2, right? So 3 to the power 6, 3 to the power 5, 3 to the power 2. If I add these two, that will be the 100th number, right? 100th term in the sequence. That you understood, right? So 100 terms in the sequence would be 3 to the power 6 plus 3 to the power 5 plus 3 to the power 2. Understood? If I add all these, I get 981. So option C is correct. I hope both the questions you liked and keep learning. Do subscribe and like the video. Thank you. Thanks a lot.